Hello, I'm going to show you guys how to multiply mixed numbers. I have a handful of examples in this video. So let's go ahead and write this out. So I'm going to make this one single term, and this is going to be another term. So we're just going to keep working term by term, and eventually we're going to combine these, right? And the reason we're doing that is because this multiplication right here, that's an indicator of putting these together. It's like a product, right? So let's write out the first term, right? 3, and we're going to do a plus in between them. We're going to do a plus sign. 1 over 3. And I'm going to do a times because it's telling me right here to do times. And we're going to do 2 plus sign 1 over 4, right? So we're essentially combining little pieces of my term inside. And then I'm going to take the second term and combine the little pieces that it gives me. And we're going to combine all of it together. So we're just working step by step on combining little pieces of it. So anytime you have a whole number against a fraction, you're going to put a little 1 underneath the whole number and turn it into a fraction, right? So now I have 4 fractions. I had 2, and now I have 4. What do I do next? Well, now I have to make sure that in this term, the denominators, the bottom parts of the number, are exactly the same. And in this term, I have to make sure the bottom numbers, or the denominator, are exactly the same. I call it the boot and hat method. And I do have a video on my channel. I think it's called the boot and hat method. I think I clearly label it as such. And the boot and hat method is basically you have to make sure when you leave your house that you're wearing the same shoes or boots, right? The hat, it doesn't matter. The hat could be anything you want it to be, but the boots have to be identical. So I'm looking right now, and my boots are not the same. I have a 1 and a 3. So I got to make sure that I'm wearing the same boots. How do I make sure I'm wearing the same boots? Well, I can multiply this by 3. That way, both of the shoes can be identical. But whatever I do to the bottom, I have to do to the top. See, so I got to multiply the whole thing. Well, what does that give me? Well, 3 times 3 right here is 9. Gives me a 9. And then the bottom is a 3. And I'm just going to bring down this right here. That gives me plus 1 over 3. So I got the first part set up, right? My shoes are the same. The hat, it doesn't matter. It's whatever it turns out to be based on my math I do. Let's do the little times thing I brought down right here, right? And now I have the same problem. I'm looking at my second term, and I have 2 different shoes on. I have to make the shoes the same. Let's multiply it by 4 so I can get the same shoes on. Whatever I do to the bottom, I gotta do to the top. And what does that give me? Well, that gives me an 8 and a 4 plus 1 over 4. All right, that's my new set I'm dealing with now. All of this became all of this now, right? It turned into that. So let's take a look. What do I have going now? Well, I'm going to add all these together. 9 plus 1 is 10. And my shoe was a 3. Times, let's see, my hat is an 8 plus 1, which gives me a 9. And my shoes are a 4. Great, great. So I had a bunch of mixed numbers. I had mixed numbers right here and mixed numbers here, and I converted them into something else. They're no longer mixed numbers. So let's go ahead and finish up this problem. What is 9 times 10? Well, it's 90. And what is 4 times 3? It's 12. Great, perfect. So this could technically be the answer, but the issue is, we are trying to find mixed number stuff. So we got to convert it into a mixed number. This is technically the answer, but I got to make it look like this stuff, this mixed number stuff, where you got a whole number and a fraction pushed up against it. How do I do that? How do I convert it into a mixed number? Well, I'm going to take the denominator, the bottom part, and I'm going to divide it by the numerator, or the top part. So on the outside is the bottom number. On the inside, here, let's write it down. I have the denominator here. I'm dividing it by the numerator. See, like that. So let's see, how many times does 12 go into 90? It goes in 7 times. And what is 12 times 7? It's 84. Yeah, 84. What does that leave me with? It leaves me a remainder of 6. Now here's the thing. My final answer is going to be in this little math problem I just did. So the setup is going to be my answer times the remainder over the denominator. And what does that mean? It's going to be 7, 6, 12, right? This is my final answer. However, we can reduce that fraction a little bit more, right? How many times does 6 go into 12? It goes in 2 times. So my final answer could also be 1 over 2, right? All 3 of these, this, and this, are all technically correct, but the answer you really want to look for is this one, right? Because we had mixed numbers and we converted it into a mixed number at the very end. This is an improper fraction. Right here. This is an improper fraction. Some teachers are cool with it. When I was younger, they were not cool with it at all. They wanted me to turn it back into a mixed number again. So that's why this was the final answer when I went to school. Let's do another example. Okay, so we're going to set it up the same way. We're going to take each term. We're just kind of going over this. We're taking each term and we're going to do a little plus sign in between. We're going to get the matching boots going. Then we're going to multiply everything together. And then we're going to see what our answer is. Maybe we can keep it like what it is, but maybe we have to do the long division thing. So let's go ahead and try it. So step 1 was take one term right here and your other term and set it up with some room. So I have the plus sign. You've got to remember that plus sign. If you don't remember the plus sign and then you're like taking a test or a quiz, you might know how to do everything pretty well, but if you just don't remember step 1, which is making sure that plus sign exists, it's going to be tricky because that's like step 1 and everything else follows. So always remember to put that plus sign in. So this was our setup. That all we did is just throw a plus sign in between those little pieces. And then anytime there is a whole number against a fraction, you put that invisible 1 in the bottom. Great, perfect. It's all set up. The next thing I do is I have to make sure that when I leave my house, my boots are the same. Can I make sure my boots are the same? Let's see. Right now, these boots are not the same. What do I do to make them the same? Well, I can multiply this by 2. I can also multiply the top by 2 because whatever I do to the bottom, I have to do to the top of that little piece of fraction. So what do I end up with? I end up with, right here, I end up with 4 over 2 plus 1 over 2. You can skip this step and just make it 5 over 2, but I'm going to keep every step here for us. Right? So we're basically done with this. What about the second part? Do my shoes match? They certainly do not. So I have to figure out how to make my shoes match. Let's make this a 4. And whatever I do downstairs, I gotta do upstairs, right? So what do I have left? I have 12 over 4 plus 1 over 4. Great. These are my new fractions I developed. So what do I do now? I just add them, right? I have a 5 over here with the 2 times, right? I got the times right here. And then I have 12 plus 1, which is 13, over 4. 12, 13. Yeah, perfect. Great. What do I do next? Well, I have this set up right here. Our goal was to multiply 2 fractions. I turned this into this. So I'm ready to just simply multiply. So what is 5 times 13? I'm just going across in the numerator, the top part. It gives me 65. What about the bottom? 2 times 4. The denominator gives me an 8. This is an improper fraction. It could be the answer, but if they're asking me to turn it back into a mixed number, which basically looks like this guy, I got to do some more work. I have to do the denominator on the outside, the numerator on the inside, and I got to do my long division stuff. So how many times does 8 go into 65? It goes in 8 times. What's 8 times 8? It's 64. The remainder is 1. Great. So my final answer is going to be in this entire little problem right here. What is it going to be? It's going to be 8. I got that from up here. And then my remainder is 1. I got that from down here. And then my denominator is always the same as the answer for my improper fraction part, which is an 8, right? Right here, the denominator. This is the final answer. I can't reduce it any further, but this is the final answer. This can technically also be the answer as well. So they're both correct. This is what they're typically looking for right here, though. Great. Let's go ahead and set it up in a different way right here. Okay, so let me go ahead and do our steps, which was do our whole number, and the very next step is to do that plus sign, 1 over 5. I think I should move that 3 higher up. Let's move the 3 higher up. Times 6 plus sign half. And then, of course, when you have a whole number against a fraction, you do those little tiny ones, right? Perfect. So we essentially like expanded, we kind of pulled apart these little terms so we can fit in a plus sign. Now I'm going to do the boot and hat method. Do my boots look alike? They certainly don't. So I got to figure out how to make the boots match. I'm going to do a 5 over here. Whatever I do downstairs, I gotta do upstairs. And let's see, what do I have? What do I end up with? Well, it looks like I end up with a 15 over 5 plus 1 over 5 times, well, let's see, can I just bring this down? No, I can't. I have to make sure that my shoes match. I can't leave the house without that. I have 2 different shoes on. So what do? I can convert this entire fraction into something else by multiplying it by 2, and whatever I do downstairs, I gotta do upstairs. So what does that give me? It gives me 12 over 2 plus 1 over 2. Great. So let's see. This is my new fractions I've set up. So what do I have? 15 plus 1 gives me 16 over 5 times 12 plus 1, which is 13 over 2. Great. Now I have this into this. That's what I turned it into, right? So I turned the mixed numbers into fractions. So now I can go ahead and start multiplying. So let's see. I think it's going to be 200 and I think it's 208, right? Let me check my calculator. 16, yeah, 208. 208 over 5 times 2 is going to be 10. When we're multiplying, it's cool to just multiply these. You don't got to make these match. The only time you use the boot and hat method is if you're adding or subtracting. If it's a plus and minus, you've got to use the boot and hat method. You do not have to do that at all with multiplication. You just multiply across. Cool. So I ended up with this number right here. So let's see. This could be the final answer. We can end up with this as our final answer. We'd have to reduce it, you know. You see how they're both even? But I'm requiring a mixed number situation, right? So let's go ahead and do that. So what does it look like? We put the denominator on the outside. right? D for denominator, outside. Think of like a house and the puppy dog lives outside. Remember in the Flintstones where they put the dog outside? I think. Was it a dog or a dinosaur? Anyways, it starts with the letter D. They go outside. And the numerator lives on the inside. So that's going to be 208. The numerator's at the top, the denominator's at the bottom. Right? Okay, cool. So how many times does 10 go into 208? It goes in 20 times. And then 10 times 20 is 200. My remainder is going to be 8, right? So my final answer is going to be inside this little math problem. So it's going to be the answer, 20, and then it's going to be the remainder at the top, which is 8, and then we're going to have the same denominator. That's 10, right? This is also my final answer. However, we can reduce that fraction up a little bit, right? We can do like a 2 and a 5 here. 2, 5. Wait, it's a 4. We could do a 4 and a 5. So our final answer could be 20, 4, and 5. Great, perfect. So all three of these can technically be right. However, we're really looking for this as the final answer because the first one is an improper fraction. The second one is correct, but it needs to be simplified. It needs to be reduced a bit. So this is the final answer as a mixed number that has already been reduced. Great, let's try a different one. So this one is like an integer in it right here. Integer is like a whole number, like 1, 2, 3, 4, 5, 6, 7, all the way to a million plus. But it also includes negative numbers. So like -5, -3, -2, -1, negative all of them, right? On the whole entire number line. So this has an integer. And it's also mixed numbers. And we're also multiplying. So let's go ahead and try to work this one out. So how do we set it up? We do the exact same thing we've been doing, but we have to be mindful of that negative sign, right? It gets tricky sometimes. You've got to be mindful of it. So let's go ahead and set it up. I have that negative whole number, which is a 5, plus sign. Don't forget the plus sign. 1/4 times 3 plus sign 3/7. Great. What do I do after that? I got to make sure that invisible 1 is there. Anytime you have a whole number against a fraction, you got to make sure that invisible little 1 is there. The next thing I do after that is I got to check if the shoes are the same. I cannot leave my house with any shoes on any which way. I got to make sure the boots match. The hat, totally secondary, but the boots got to match. I can't leave my house without it, right? Cool. So I got to make sure the boots match. So I'm going to do a 4 here. Whatever I do downstairs has to go upstairs as well. So what do I end up with? I end up with a negative. Don't forget that negative. It's getting messy, right? So we can overlook it. So I have 20 up here, right? Because 4 times 5 is 20. With that 4 plus sign, 1/4 times. Can I bring everything down with the second term? No, I have to make it match before I can bring it down. So what can I do? I have a 7 and a 1. I can multiply the bottom by 7 to get the same shoes going. And then whatever I do at the bottom, I gotta do to the top. So what does that give me? 7 times 3 is 21. 21? I don't know why I can't remember all of a sudden. Yeah, it's 21. Okay, it's 21/7 plus 3/7, right? That's my new term. Great. So after I set that up, -20, perfect. Okay. So with this stuff, we have to just keep adding across, like when we're doing mixed numbers. So this would actually be 21, -21 right here. It wouldn't be -19. We just add across. You're essentially just kind of like adding. Here, let me show you. I don't know if this would be useful. Now, typically, you look at this and you're thinking, okay, maybe that's -19. This time, what we're doing is we're just, with mixed numbers, we're just adding the 21 together, the 20 and the 1 together. And we're just going to remember to put that negative sign there, if that makes sense. I don't know if those parentheses kind of help indicate what's happening. right? Perfect. And then I put the 4 in the bottom. And then I have, let's see, the 20 times. That's a positive, so it's 24 and 7. Great. So that's what I have set up. That's my new fractions. I had mixed numbers, and now they're just becoming standard fractions, improper fractions, rather. So now I could multiply across. I can multiply across and then just start reducing everything. But what I could also do is I can look really carefully at these. I'm looking at my 4 and I'm looking at my 24, and I'm noticing, well, those, we can reduce those. How many times does 4 go into 24? It goes in 6 times. It goes in evenly 6 times. How many times does 7 go into 21? It goes in 3 times. 3 times. So what does that give me? It actually gives me negative 3. Don't forget that negative. You got to bring it down. It gives me negative 3 over 1 times positive 6 over 1. And what does negative 3 times 6 give me? It gives me negative 18 over 1. And that just becomes 18, negative. This is actually the final answer right here. Sometimes when you are multiplying right here on this stage, when we were multiplying these these improper fractions, you can start reducing in a different way. You don't necessarily have to multiply across. You could, in fact, multiply across and just keep doing everything we're doing, but this method is a little bit faster. I think it also reduces your opportunity for mistakes simply because we're dealing with smaller numbers. We're not dealing with numbers in the 3 digits, which we would go into if we started multiplying across. So we're only dealing with simple numbers. Right? But of course, both methods are appropriate. You can use both methods. I believe this is my last example. So let's go ahead and try it out. So of course, step 1 is, okay, we have negatives. We got to make sure we keep those, okay? So step 1 is we're going to rewrite the terms with those little plus signs. So we're going to do a 4 plus 9 over 10 times negative, don't forget the negative, 3 plus 3 over 7. Great, so I have the plus signs in there, and then I have the negative signs, which I did not forget. So what's the next thing I do? I got to make sure those whole numbers got a little tiny baby 1 underneath it, because anytime there's a whole number against a fraction, I got to make sure that my whole numbers turn into fractions. Great, what's the very next thing I do after that? Well, I'm about to leave the house, so I got to make sure that my boots match, right? I'm looking over here and my boots don't match. So how can I make them match? I put a 10 here. And whatever I do downstairs, you gotta do upstairs. So what does that leave me with? It leaves with negative, don't forget that negative, 40 over 10 plus 9 over 10. And it also gives me, oh, we haven't done that part yet. Okay, so I did the multiplication thing. I brought it down right here. And now I got to check the second term. I have shoes that do not match again. So I got to find another pair of shoes in my closet that are going to match. How do I do that? Well, I put a 7 down here. And I also throw a 7 upstairs. Whatever you do downstairs, you got to do upstairs also. So what does that leave me with? It leaves me with 21. And let's see. Oh, I forgot the negative sign. Negative 21 over 7 plus 3 over 7, right? So we have this first part right here, and then I got the second part right over here. Now we get to put everything together. So I'm going to have negative 49, right? Because what we're doing is we're just adding them together with that minus sign, right? 10. The shoes are the same, times. What are we doing? We're doing the negative sign, and all we're doing is adding this and this together, right? Just like we did here. We added this and this together. We threw the negative sign up front. So 21 plus 3 is 24 over 7, right? This is my new fractions. I had mixed numbers here, and then I turned it into these improper fractions. Great. So let's see. What can I do? Well, I believe we can do the same method we did earlier. See how right here? We can put these together right here. And we can put these together right here. So let's try that. How many times does, let's see, 5, let's do 7 and 49. That goes in 7 times, but we got to make it -7. So the 10 and the 24 don't evenly go in because it would be like it'd be left with a 4 with the remainder of 4 right here. So let's go ahead and just divide it by half. I could turn, that's a 7. I could turn this into a 5. I just divided it by half, and I could turn this into a -12. We're just dividing it by half. So what does that give me? I'm just rewriting it. I'm just bringing it all down over here. We're just rewriting it. It gives me a -7 over 5 times a -12 over 1. That's what I ended up with, because I put these together, and then I put this together. Okay, cool, sweet. Let's go ahead and finish this up. So what does that give me? It gives me -7 times -12 is positive, so I get an 84 here. And then the denominator, I got a 5 because 5 times 1 is 5. This is my answer. It's an improper fraction. So I got to do that thing with long division where I have to turn it back into a mixed number. And the rules are the denominator, which is at the bottom, lives outside, like the Flintstones example, and then the numerator lives on the inside of the house. How many times does 5 go into 84? 16 times. What is 5 times 16? It's 80. What's my remainder? It's a 4. So my final answer is going to be 16 that I got up here. It's going to be the remainder that I got down here. And the denominator is always the same as like the improper fraction thing. And that's going to be a 5. This is my final answer right over here. This can also be the final answer, but it's improper. So if it's going to say, here, multiply the mixed numbers and then give me a mixed number back, you have to complete this step right here. It's just long division. And just remember the denominator lives on the outside. Okay, I hope this helped. And I do have a sticker shop if you guys want to check it out. Okay, thanks, bye.